Okay, guys, let's do some more notes. So I'm just going to do some basic notes about evolution now. So let's call this set of notes the evolution notes. Maybe part one. And just some basics about, what evolution is. So first of all, evolution is just the change of species over time. So the change of species, but also in addition to the change of species, the development of new species. Over time. So we can start out with, like one species, and then it may be over like a million years or something, it actually, gives rise to more species. So you have like a family of species that maybe includes 5 species or something, right? And so if you were to like go back down the evolutionary tree, way back in time, you would eventually go to the oldest ancestor of all living things. And so one major part of the theory of evolution is that all living things share a common ancestor. So all living things that are now extinct, things that live on the planet, okay? All living things on Earth that have ever lived on Earth are descended from a common ancestor. Are descended from a common ancestor. So if you went far enough back in time, you would find the original living thing. Okay. And the way that species change and develop is through natural selection. So natural selection, and then to a smaller degree, sexual selection, because sexual selection only occurs in creatures that actually have biological sexes, which is not all creatures. Mostly it's animals and plants have biological sexes, so not all living things do. And sexual selection most often occurs in animals. So natural selection, and to a lesser degree, sexual selection. Are how changes in organisms and populations are made over a few generations. Sometimes it could even just be one generation, right? Okay. And then if you were to add up like all the little changes that might happen over 1 or 2 generations, so the sum of small changes across hundreds, thousands, or maybe even millions of generations that's what creates like a new species. That gives rise to or creates new species. So if we think about our finches, I turn off the page a little bit, or well, what you guys can see, when scooch over. If you think about like the finches that we talked about in term 1, over like a short amount of time, because of that drought that happened on their island, the beaks in that population of birds got bigger, right? So if changes like that were to happen over many generations, then you could end up with completely different species of bird from the one you started out with, right? And in fact, that's one of the things that Darwin saw when he went to the Galapagos Islands. He's like, oh, there's all these birds. They're basically really the same, but they all have like these different beaks and kind of different ways of living. and they were different species, they couldn't have offspring with each other. And so that was really interesting, and was actually one of the ways that he figured out how evolution works, right? So so these little changes that happen over like 1 generations or 2 generations, all of those added up over hundreds and thousands of generations over lots of time, that can give rise to new species. And especially if you have like populations that get split up, so you have like a population of squirrels or something, and then a big river comes into existence in the middle of their territory and ends up like splitting that population. There's squirrels on one side of the river and squirrels on the other side of the river. And then over thousands of years, they could end up being different species from each other. So when new species form, that is called that's called speciation. So that's just like a little vocab word for you. Okay. Speciation. So we've talked a lot about natural selection and how that works. Speciation is just like adding up all those little changes from natural selection or sexual selection over many generations to make a new species. And so that's kind of like our nitty-gritty of evolution. And then we're going to talk about like the major lines of evidence for evolution. And we're going to have that be our evolution notes part 2. So I'm actually just going to get started on that. I'm going to scooch this up a little bit. You guys can switch pages if you want. So evolution notes part 2. And I have a whole slideshow that has pictures and examples and stuff. So I'm going to kind of just make an outline, and then you guys will be able to fill it in. Okay, so it's really about the evidence for evolution. And I know that you went over a lot of the evidence for evolution when you did your station lab. Okay, so this is just kind of recapping that and making sure that it's in your notebook so you can use it. Okay, so we have a few different major types of evidence for evolution. We have the fossil record. Okay, and I'm just gonna take a moment here to draw a picture to go along with what you're gonna write when you look at the slideshow. Okay, and we're gonna leave some space open for that. So I'm just drawing a picture of some layers of rock, right? So this is layer 1, layer 2, layer 3, and then maybe here's the surface of the earth. And so we've got some grass. Maybe we have a flower. You know how beautiful Ms. Munson drawings are. There we are. Okay, I'm gonna make it a little bush over here. All right, so here we have the ground. And then beneath the ground, we have all these layers upon layers of rock, right? So typically when we're looking at fossils, we have the youngest, like the most recent fossils are going to be right at the surface. Okay, so those are the things that have died and been buried and fossilized most recently. And then at the bottom, we have our most ancient fossils. Now, sometimes when like, you know, earthquakes happen or other kind of geologic things happen to switch up the order of the layers, this gets, you know, disturbed. But for the most part, we're looking at something like this where the most ancient are at the bottom and the most recent are at the top. Okay, and so you guys could draw in a couple fossils if you want. So we'll have like sea creatures here at the bottom, because we pretty much had sea creatures for a really long time, right? Then maybe you could put a dinosaur skull or something. It has teeth, right? Maybe a really big bone, because we had some animals that had really big bones in that middle kind of time. And of course, we have many eras. You'll see on the slideshow all the different eras. And then at the top here, I'm going to put like a smaller little skull, because now we have smaller creatures. I'm going to put a small bone in there, and maybe a shell or two for fun. Maybe a piece of amber. I don't know. So I'm just doing a quick drawing just to remind myself of fossils, right? So we have fossils And of course, we go back over to the writing part. Fossils are rocks that formed in the molds left by living things. So if I was walking in some mud, I might leave a footprint, and then that footprint might harden because the mud gets hard. And then over time, that mud might turn into rock, and then it might get buried. And then a new rock might form where my footprint was, and then you would have a fossil impression of my footprint, right? So just remembering how fossils are formed. So that's where fossils come from. I'm just gonna leave you the rest of this space to fill in when you're looking at the slideshow. And on the slideshow, you only have to write the things that have a red squares. Okay, so when you're looking at the slides in a little bit, you're only going to write the things that have red squares. You don't have to write everything. The other stuff is like optional. If you want to put it in your notebook, you could. There's a lot of examples and stuff for you guys to look at. Not necessarily have to write every word that's on that slideshow. Okay. All right. All right, so we're going to continue with our evolution notes part 2. So the other kinds of major evidence for evolution are vestigial structures, I just want to go over to that slideshow so I make sure I do it in the right order. And just take a gander at that. Where do I have it? Okay. I don't want to get you guys all messed up with the wrong order. Oh, I already did get you messed up. I think homologous structures were first. Darn it. Oh well, let's just go with it. So we'll do vestigial structures. I'm just going to leave you some space here, right? I am going to draw a picture example. So I'm going to draw like a whale tail, because one of the sort of classic vestigial structures are hip bones in a whale. Okay. And I like to think of vestigial structures of like, they're like the leftovers from ancient ancestors, right? So it's like, okay, the whale, goodness, what happened? Put a Y instead of an S. Leftovers from ancient ancestors. Okay, so like the whale had ancient ancestors that had legs, and so they still have all of these bones in here that are for like the hips and the legs, but they don't need hips and legs, right? And so this is like a classic example of a vestigial structure. And there are more examples in your slides. Then we have homologous structures. I'm going to leave some space for you to write stuff here, right, from the slideshow. Then we have homologous structures. And homologous structures, they have like the same anatomy, but used differently, right? So is there any reason why like our arms and a bat wing would need to have the same number of bones in the same order? Not really, but they are. And so that's something that we use to say like, oh, okay, so maybe we actually were both mammals too. Maybe we came from common ancestor, right? So same anatomy, but used differently. And I'm going to leave some space there for you guys to write some stuff. And then we're going to go to biochemical evidence. Okay, biochemical evidence is one that you didn't talk about on your station lab, but it's super powerful. Okay, so biochemical evidence, this is like the fact that all living things use the same DNA code and mechanisms for using DNA and building proteins. And there are many ways that this could have been done, but this is the only way that it's done. So this is strong evidence. And we'll leave you some space to add some ideas from the slides. And then the last thing, the last sort of branch is embryological evidence. Okay. And this has to do with similarities of embryos at different stages, which you guys got a good look at in your station lab. So like the embryo of many different kinds of animals, including fish, right? Like look really, really similar to even human embryos at those early stages. So it's like as the development continues, then changes are made, but we start out with the same basic plan and then we just kind of use it in different ways. Just like we are all using the same mechanism for DNA, even though our DNA says different things, right? Okay. All right, we're going to stop there and I'm going to send you over to continue the slideshow and all the slides that are on there. All right, take care. I can't wait to see you next week. Really, really.